Now let's go over factoring. Three things you must know with factoring are three important formulas. The first formula is the difference of squares. So if you have a squared minus b squared, then that can be written as a plus b, a minus b. You might want to write these formulas down before we begin. Also, if you have a quadratic in the form of x squared plus bx plus c, and there is no number attached to the x squared, this can be completed by doing what's called the PQ method, which is you take two numbers p and q, they have to multiply to give you c, which is the last number, and they have to add to give you b, which is the second number, the number connected to x. So the same two numbers that multiply to give you c have to also add to give you b. If you can accomplish that task, then you can write it as x plus p times parentheses x plus q. Now if you have a number attached to x squared, that's a totally different story, which takes a little bit more work. You have to do what's called the AC method, which you take a, the number attached to x squared, multiplied times c, the last number. Once you obtain that, then you have to do the PQ method inside of it. So you have to find two numbers p and q that will give you the result of those two numbers you multiplied when you took a times c. And the p and q, the same two numbers also have to add to give you b, sort of like the PQ method. But once you find those two numbers, then you put x by them. What that does is p plus q equals b, as you can see here. So instead of having a bx, you have a px plus qx because they add to give you bx. So the whole point of the AC method is trying to split up the middle term, the bx, in the way that when you factor it by grouping, it just falls right in your lap. And then lastly, if you have a polynomial that you can't factor, you just call it prime. So the key thing that you must know is that when you look at a problem, what strategy should you apply? So let's start off with having the number 3x squared minus 192. So the thing you must know is that look at the 3x squared and 192 and you want to ask yourself, what do these two terms have in common? This is not a difference of squares because 3 is not a square of any number. So that means something needs to be done first. What can be done, you look at 192 and you look at 3 and you want to ask yourself, do they have anything in common? Can 192 be divided by 3? And the answer is yes. So you pull a 3 out and what you have left is x squared minus 64. Then you got to ask yourself, am I finished with this problem? And the answer is no, because x squared minus 64 can be written as x squared minus 8 squared. And because 8 squared is 64, when you look at it, this is a difference of squares. So when you write it, it's going to be x plus 8 times x minus 8. And this will be the finished product. So this is what this problem factors into. Okay, let's say we're given a problem 2x squared minus 11x plus 12. Well, because we have a number connected to our x squared, that means we have AC method. So we take the 2 times the 12 and we get 24. So we must find two numbers and multiply to give us a positive 24 and have to add to give us a negative 11. And so if it's difficult to find those two numbers, you do a tree with 24. So the ways you can get 24 are 6 times 4. You can break up 6 with 3 times 2. And you can break up 4 with 2 times 2. So 24 is really 3 times 2 times 2 times 2. Now you can take any different combinations of these numbers. If I look at 2 times 2 times 2, that will give me 8. 8 times 3 is also 24. And when you add it up, 8 plus 3 is 11. So how do I get a negative 11 out of that? Well, if 3 and 8 are negative. So my two numbers are, you have 2x squared minus 8x minus 3x plus 12. So 8 and 3 were my two magical numbers, and they add up to give me a negative 11. Now you look at this first piece here, and you want to factor out those two. 2x squared and negative 8x. They both share an x and a 2. So I can pull out a 2x. And what I have on the inside is I have an x minus 4. Okay, and then you look at this piece, you got a negative 3x and a positive 12. Well, since I have a minus here, and this is a positive, that means I need to pull out a negative number. So I'll pull out a negative 3, and what I'll end up having is x minus 4. And because these match, you can put the 2x and a negative 3 together. So you have 2x minus 3 in its own parentheses, and in parentheses you have x minus 4. So the result is 2x minus 3 times x minus 4. Let's say we're given a weird equation that looks like 20x to the third power minus 4x to the second minus the 72x. Well, this has a lot of x's in it, so I know that since all three terms have x's in it, I can factor an x out. Now, the question I want to ask myself is, I know that 4 is inside of 20, but the question is, is 4 inside of 72? And the answer is yes, so I can pull a 4 out of everything. So what I can pull out is a 4x. So what I'll end up having is a 5x to the second, because 4 times 5 will be 20, x cubed, minus x, because all I need is a x to give me a negative 4x squared, and minus 18. So this is where I'm at now. And then I look at the inside, and I see that this is an AC method problem. So the 4x, you're going to leave the 4x alone right now and just deal with it at the very end. But right now we need to break up this 5x squared minus x minus 18. So by the AC method, we have to multiply 5 times negative 18. So 5 times negative 18 will give us a negative 90. So we need to find two numbers to multiply to give us negative 90 and add to give us negative 1. Well, if they add to give us negative 1, then that means that those two numbers are very, very close to each other. So what are the different ways you can get 90? Well, they only one apart, so I know that 10 times 9 is 90. And so since the negative number is in the middle, that means my 10 is negative and my 9 is positive. So the way I break it up is 5x squared minus 10x plus 9x minus 18. And so I do my factoring by grouping. So what can I pull out of the first one? I can pull a 5 and an x out. So when I pull a 5 and an x out, I'm left with x minus 2. And then when I look at this one, they both have 9 in common, so I pull out a 9 and I'm left with an x minus 2. So because these match, I can put these together and I have 5x plus 9 in one parenthesis and then the x minus 2 in the other. And don't forget that you have 4x here sitting on the outside, so you bring that down and this will be your final answer. Let's say, for example, when you get your negative 10x and your positive 9, you don't write it in the way that we write it. So you write it as a 5x squared plus 9x minus 10x minus 18. So instead of writing minus 10x plus 9, you write a plus 9 minus 10. This way it should still come out the same. So when you look at the first two, you can pull an x out. That's all you can pull out, and you end up with a 5x plus 9 in that one. When you look at this one, since this is positive in the middle and this is negative, you want to pull out a negative number. 10 and 18 both share 2, or they also share another number. So I'm going to pull out a negative 2, and what I'm left with is a positive 5x and a positive 9. Because negative 2 times 5x is negative 10x. Negative 2 times positive 9 is negative 18. So since these match, I put my x minus 2 together, and then I bring down my 5x plus 9. So you essentially still get the same answer that we got here, even if you rearrange the 9 and negative 10. It doesn't really matter. Let's say we're given x squared minus 6x plus 1. Well, since we don't have a number in front of x squared, we can do this by the PQ method. But the PQ method tells us that we need to find two numbers that multiply to give us 1 and add to give us a -6. It's only one way we can get 1, is that's 1 times 1. Since none of those numbers add up to give us -6, this polynomial is prime, which means it can't be factored. It can be factored